In this tutorial, we're going to review revenue problems as applications of quadratic functions. So in general, a revenue function is where you are selling items and you sell them for a price. So you're going to take the price per item times the quantity and multiply it together. So if you sell something for $5 a piece, for instance, and you sell 10 of them, that means you make $50 in revenue. Okay, so not profit, not loss, just all the money you're bringing in. So we're going to look at problems that ask us to maximize the revenue because that's what many businesses are interested in doing, earning the maximum amount of money or bringing the maximum amount in. A skateboard shop sells 50 skateboards per week when it charges $70 per skateboard. For each $1 decrease in price, about one more skateboard per week is sold. Write an equation in intercept form to represent this. Okay, well, intercept form would be something like this. R of X equals, and what do they sell? So we do price times the quantity. All right, so they sell about 50 skateboards, it says, and it charges $70. So normally we just do 70 times 50, but they've discovered that when they change the price, something happens. For each $1 decrease in price, so when the price drops by $1, and it's dropping multiple times. So I'm going to say over here that X is equal to the number of price changes because I'm changing it multiple times. And when they drop the price, they sell about one more per skateboard. Now, not 50 plus 1, but 1 per price change, so 1X. At what price should the shop sell the skateboards to reach the maximum weekly revenue? Well, this ends up being, if I change this to standard form, you'll see it's going to be a parabola that opens upside down. I need to find the vertex to answer the remaining questions. So to give myself some space here, I am going to just continue down here, and I'm going to convert my function into standard form. So the 70 minus 1x and the 50 plus 1x. So I'm going to convert this to standard form, giving me 3,500 plus 70x minus 50x minus x squared shows me that my function is negative x squared plus 20x plus 3,500 for my revenue. So to find my vertex, that's negative b over 2a for the x value. So that would be equal to negative 20 over 2 times negative 1 would be negative 20 divided by negative 2 or positive 10. So that means that my x value is 10. My y value would be by finding r of 10. So I just plugged 10 into my function. And when I evaluate that, I get 3,600. So there's my y value. So I need to remind you that this is the number of price changes. And my y value is my revenue because see, this is in the y spot, this was revenue. X at the beginning was the number of times we altered our price. So that's my vertex, but we are asked to answer 2 questions now that we have our vertex. They're pretty simple. Part C is the easiest. We got that, the maximum revenue. We just said that's our y, okay? It's the highest it reaches right there. At what price should they sell these skateboards though? They don't sell them for $10. That means they need to change their price 10 times. So a couple ways you could think this through. I find it easiest to go back to my revenue function where it was 70 minus 1x. That's the price portion. And what I do is I start substituting. I do 70 minus 1 times x. Well, x is 10. So 70 minus 10 would be $60 per board. We're going to do one more example. We'll again begin by setting up our revenue functions. I'm going to do r of x. Let's see. So a store sells 40 video games each month. Again, I'm going to do price times the quantity and they sell 40 and they're charging 200. And for each $10 increase in price, so the price here is going up 10, it's going up, could go up twice, 3 times, 4 times, so plus 10x, they sell about 1 less. So this is dropping by 1 each time, so minus 1x. There's my revenue function. Again, I'm going to be finding things about the maximum. So down here, I'm going to find the vertex. And I just want to remind you of an alternative way to find your vertex. Okay, you could use a relationship that it's halfway between your two x-intercepts where you add p plus q and divide it by 2. So it's actually, I think, a little simpler to do it that way, I think, because it's factored. So your x-intercepts would let them each be equal to 0. 200 plus 10x equals 0. So I subtract 200 would give me 10x equals negative 200. Divide by 10, and I get x equals negative 20. And the other one, 40 minus 1x, would be equal to 0 by the zero product property. And if I add 1x to both sides, I get 40 equals x. Okay, so my two x-intercepts are here. So to find my vertex, what do? Well, I add them together and then chop them in half. Negative 20 plus 40 cut in half would be 10. This would be 20 divided by 2. So 10 price changes, and then how do I get the y value? Well, I do r of 10. So I take my original function, the 200 plus 10, and I plug in 10. 10 times 10 times, I'm just out of space here, let me just slide it over, times 40 minus 1 times 10. So that's going to be what, 300 times 30 would be $9,000. All right, so here's my vertex right here. And now I can go back and answer the questions, because if I have a parabola that opens downward and there's my vertex at 10, 9,000, the revenue is your y, your r of x, and change the price 10 times. So at what price should they sell it? Again, if I take my price portion, the 200 plus 10x, and I plug in 10, that's going to be $300. So you can decide which way you like best. Did you like it how we did the first one, where you changed it to standard form, or work off your knowledge of all your intercepts?